The next property that I want to discuss with you deals with the derivation of the cost function of a Cobb-Douglas production function. Now remember, in earlier problems which we dealt with, where we used to find out the profit function, profit is always described as TR minus TC, where both total revenue and total cost functions are functions of Q, or the output being produced and sold. So our attempt here is to find the total cost function, or TC, as a function of Q. Now the information already with us is that the production function follows a Cobb-Douglas formula represented by Q is equal to A times L to the power alpha K to the power beta. The cost function as a function of labor and capital units employed can be expressed as W times L plus R times K. And we know that a rational producer would always use the least cost combination of inputs in order to produce any given target of output. And all such equilibrium points will fall along the expansion path. Whose equation is beta times WL minus alpha times RK equal to 0. Now, if we manage to solve these three bits of information, or these three equations simultaneously, we will actually end up deriving the cost as a function of the output being produced. So let's go about it. As a first step, using my expansion path. So to solve these three equations simultaneously, my first step is to multiply equation 2 with alpha, which will give me alpha times WL plus alpha times RK is equal to alpha times C. Now, adding, I'm calling this equation 4. So if I add equation 3 and equation 4, I will get, as you can see here, minus alpha times RK and plus alpha times RK cancel out, giving us alpha plus beta times WL is equal to alpha C. Here, I can express L as alpha by alpha plus beta times W times C. Now, I'm naming this equation 5. Now my next step would be to use this information or relation from equation 5 into my second equation. So doing that, I will get it as C is equal to W times alpha by alpha plus beta W into C plus R times K. Here, taking alpha by alpha plus beta times c to the left hand side. I get it in this form. Next, I take c common, so I get 1 minus alpha by alpha plus beta in the brackets. Within the brackets, take alpha plus beta as the LCM. So, alpha plus beta minus alpha comes in the numerator. Positive and negative alpha cancel out each other. And now I can write k in terms of c as beta by alpha plus beta times r into c. I call this relation 6. My final step is to use relation 6 where k is expressed in terms of c, and relation 5 where L is expressed in terms of C, and substitute it into my first equation, which is the production function. So when I do that, what I get is instead of k, I substitute information from equation 6. Now using the rules of exponents, I shall open up the brackets so that I get a times alpha to the power alpha divided by into beta to the power beta divided by alpha plus beta to the power beta r to the power beta and c to the power beta. Now once again, using the product rule of exponents, that is a to the power m into a to the power n can be written as a to the power m plus n. I can write this as a times alpha to the power alpha into beta to the power beta divided by alpha plus beta to the power alpha plus beta into w to the power alpha r to the power beta into c to the power alpha plus beta. Now remember, our intention is to express c as a function of q. So using the rule of exponent, that if you have a to the power m is equal to b, you can express a as the mth root of b. So using that information, I can write c as equal to a times alpha plus beta to the power alpha plus beta into w to the power alpha r to the power beta divided by alpha to the power alpha into beta to the power beta into q whole raised to the power 1 by alpha plus beta. So this is the production function, or rather the cost function associated with a Cobb-Douglas production function. Now I will add one more qualification to this derivation. That is, for a linearly homogeneous Cobb-Douglas production function, since degree of homogeneity is alpha plus beta, it will be equal to 1. So the cost function will look like this: a times w to the power alpha r to the power 1 minus alpha divided by alpha to the power alpha 1 minus alpha to the power 1 minus alpha into q. Sorry, one mistake there. A comes in the denominator. Here, since alpha plus beta is equal to 1, I have expressed beta as 1 minus alpha. And thus we have derived the cost function associated with the linearly homogeneous Cobb-Douglas production function.